we are here today with Marcos, Marina, and Zoltan to talk to you about the role of maintenance, QA, and security when we are considering an enterprise distribution like SUSE produce. My name is Marco Varlese, and I'm an architect here in SUSE. And I would like now to introduce Marcos, Marina, and Zoltan. Marina, if you could basically start yourself introducing, please.
So, hello everybody, and thanks for joining this session. I am Marina Latini, a maintenance release coordination engineer from the MSQA department.
Thank you, Marina. Marcos, would you like to introduce yourself, please?
Yeah, I'm Marcus Meissner. I'm project manager for security, also in the same department as Marina. I've been with SUSE for 18 years now and being 7 years project manager.
Thanks, Marcus. Zoltan, last but not least, can you introduce yourself, please?
Hi there, I'm Zoltan Balogh, and I'm one of the team leaders in the maintenance QA and the maintenance department, fellow colleagues of the other two, Marina and Marcus.
Thank you, Zoltan. So let's get started. I would really like to start with an easy question, hopefully. One aspect which really sometimes controversial is what is the difference between maintenance and a standard software update? Marina, would you mind to take this one and trying to help us here?
Let me try. So we can think at software maintenance as what is needed for continuously improving the quality, the security, and the maintainability, in our case, of SUSE solutions across their whole life cycle. All the people from maintenance coordination, maintenance security, and maintenance QA works obviously together for achieving this important goal. So the concept of maintenance at SUSE was born in September 2001, and it didn't exist before. As often can happen in these cases, it was triggered by the needs of customers. And you can think at maintenance as everything that happens after a product or a service pack is released, and it's normally includes security updates and general bug fixes. If you try to compare maintenance update with a normal update, a maintenance one is released periodically, less frequently than a classic software update, and we are usually trying to keep to solve several challenges for delivering something that has the good quality for our customers. So we have several challenges to keep in mind. We want to fix bugs, obviously, but we don't want to change the existing functionalities. We prefer, when possible, to backport fixes from upstream instead of, for example, increasing the version number of a package. So obviously, we don't want to introduce regressions or maybe a new bug for fixing an existing bug. So for achieving this goal, it's always important to keep the ABI and the API compatible. And we also need to be sure that all the PTFs, the program temporary fixes, are already provided to the customer, are included in a new maintenance update. So this is in general what is maintenance.
Thank you, Marina. It sounds really like interesting and also very challenging, I suppose. Marcus, something that I would like to ask you instead, like in this picture that Marina painted, security obviously is going to represent a very important part of a maintenance update. We know there are several different types of bugs which can open up security concerns. And so I wonder, how do you actually take care of security? What is the workflow that you follow when keeping an eye on security when it's about an update, a maintenance update in this case? Can you help me with that, please?
Sure. Yeah, so we from security, we are handling the software security side, so our product securities, and we cover both SUSE Linux Enterprise products and openSUSE. We also cover SUSE Manager, CASP, and others. You can split the work that we do basically in two parts: the stuff that we do before releasing a product and the stuff that we do after. The stuff that we do before is things like reviewing design, auditing packages for software flaws, and so on. But let me more focus on the side that we do afterwards. We call it reactive security. Occasionally, it's called security incident response, and that covers handling all the security issues in our products. So how do we do that? We have actually a team of people, of currently 4 people, with me overseeing this group, that takes care of processing all known CVEs, all reports that we get over public channels and also over confidential channels to us. We evaluate every CVE, every of those common vulnerability enumerators, see if it affects the product. If it affects the product, we open a bug in our tracking tool in Bugzilla, and we also review in which code streams and which products this respective security problem exists. And then we coordinate together with the other parts of SUSE R&D that the issue gets fixed, that it gets submitted to us on time, and then basically we process it and hand it over to Zoltan's and the QA team. And the QA team then in the end looks at it, and once they confirm it's good, we release the update. We also take care of documentation around it. So everything about this kind of security response we take care of.
Okay, thank you. Something that I believe it's somehow related to the description that you made. Eventually, for every single maintenance update, you are going to have multiple security fixes. And I really wonder, what is the approach that you apply here with regards to prioritization? Because I believe one thing won't be as important as another one. So there must be a priority call that you're going to make. Can you explain me a little bit about that?
Yeah, so this is something that we are doing during the evaluation of the CVE here locally. We evaluate the impact in general on the software and even on our product. So for instance, our product might not have all problems that the actual software has. Out of that, we extract a rating, or actually 2 ratings. We extract the so-called Common Vulnerability Scoring System rating, version 3. That's a lot of identifiers, indicators that result in the end in a number between 0 and 10. And we also do a simplified rating, low, moderate, important, and critical. And depending on this rating, we prioritize our work. So important and critical updates are processed faster and get to the customers faster than the moderate and low ones. And also, we have a very special process called the high impact vulnerability process, where we handle these high severe cases that happens like 2 or 3 times or 5 times a year, where people really want updates right now. These have special conditions. They have a special team handling that, the so-called emergency update team, and a special process where we deliver also additional documentation to our customers, because our customers not just are interested in updates at this time, but also in information about it. Because usually we deliver like 2,000 security issues per year, fixes for security issues per year. Most of them go through automatically, but around 5 to 10 are more interesting to customers, and there we need to supply also more detailed information about them.
Thank you, Marcus, for clarifying this to me. Zoltan, I would like now to to ask you something, because Marcus mentioned it earlier that in the workflow, obviously the QA is going to have an important role in the overall maintenance update. Can you explain me what is the end goal of your team when it's about quality assurance, and how you actually guarantee the quality of a maintenance update?
Yeah, thank you for the question. Yeah, the easy answer would be that we have a QA team. But that's a little bit too short for that. I think the secret sauce in our department to guarantee, to assure the quality of the maintenance update is a fairly rigid workflow, which starts, as Marcus mentioned, starts from the coordination team, who overlooks the priorities, overlooks what components are coming into one update, and that update is going through a pipeline where we have automatic tests for validating bug fixes, validating if there is a regression, feature regression goes by the update. We have various test coverage. It's a rather challenging domain as we need to. I mean, you can imagine tens of thousands of upstream projects coming different codes, and to validate in a speedy manner that that the bug fix, what is coming in, actually is fixing the bug. We need to check that if we have automatic tests for that, then it's triggered and executed. And we have a small team of super mean and very talented people who are really experts on testing everything. So we have a small manual testing team who can cover those areas where we don't have automatic tests. I think the long answer is test automation and separated bug fix validation, regression test, installation test, and functionality test executed with massive paper trail. Lots of logs, and we are watching very close to many numbers, metrics, how we are doing, and following that up to see if something goes wrong. So rigid process, a heavy workflow, and well-staged pipeline.
Thanks, Zoltan. So I believe that, as you said, automation, I believe it's really the important word here. So what kind of tools and technology do you actually use for such a validation, right?
Yeah. So the core, the center of quality assurance for maintenance QA is exactly the same as the product line QA, and in many areas, and for openSUSE as well. That's the openQA tool. That's a big and massive tool. It was built to validate operating system, to validate SUSE, validate different SUSE streamlines. So it's a bigger tool. Look it up, openQA, Google it up. It's a wonderful and big tool that helps a lot. So we are contributing to that framework as well. That's a big tool, and we are creating test coverages for the most critical packages. So we follow what packages are coming in more often, what are the more troublesome packages, what are the risky packages, and we develop maintenance-specific test coverage for older products. So that's the other one. We have those plugin-like tests. These are actually the I would say 90% of the test automation. And of course, we do implement our own tools. So we have a database, massive database developed by the coordination team, historical data of tens of thousands of updates since time for 2014. And we are data mining that. So we learn a lot from that data. And we have lots of small tools, how to deploy, how to start reference hosts, how to build the test environments quickly. That is the way to save time. So openQA is the core. Test cases implemented for openQA are the real beef, and lots of small tools around it.
Thank you, Zoltan. I would like now to shift a little bit the view on the problem, and I would like to basically pose a question from somebody like an end user. So let's imagine that I'm using the product, and now I am facing an issue, and I I'm reporting this issue, I already know how to report the issue. How is the issue then solved from a maintenance point of view? What happens now once I open the bug?
Let me take this one. So obviously we are talking about maintenance, so we are not directly interacting with you having the issue, but we are getting a submission, a maintenance request that it's already providing several information to us for understanding if the submission it's something that can be delivered to the final user, to the final customer. So what we are doing is to evaluate all these informations. Usually we have information through Bugzilla, and with Bugzilla we can immediately understand which is the code stream, which is the product that is affected. In the submission we have really often other comments provided by the developer with, for example, other useful information for understanding how important is this update and how fast we should process, for example, this particular update. So the first screening, it's exactly this. We are evaluating everything, and always keeping in mind the previous challenges that I was describing before. And when everything from our point of view seems to be effectively something that can be shipped to the customer, to the final users, we are accepting the request, and we are also adding what is called patch info. That is a description of what has been updated by that particular update. So who is getting this update can also read what exactly has been changed. And obviously this one is not the unique part of the job. We are doing this first screening, and when from the maintenance coordinator the update it's ready, we are moving the incident to the QA team that is doing all the other tests that Zoltan was mentioning before. And when from their point of view the fix is it's appropriate, they are giving back the task to us, and we can finally read the report and decide if we can finally ship the update to the user.
Okay, great. So basically, this is the story from the end user perspective. Now, as I am a developer myself, I would really like to understand, once a bug is open, obviously I am the assignee of the bug, I need to fix this. And now I have fixed it, I've submitted all my patches, all my code is ready. How then my code eventually hits the distribution? What happens now?
So first of all, thanks for submitting the update. Jokes apart. As you can imagine, also in this case, there are several interactions. Our team is usually interacting with other, not our team only, our department. It's usually interacting with all the other people that are developing the products. So what is happening from a developer point of view is that usually the developer knows where the issue should be submitted, so for which code stream the issue should be submitted. And in that case, we should evaluate, first of all, if that package, it's a package that comes from SLE, so from directly a SUSE product, or if it's something that is directly in openSUSE. So that one probably as developer is the first different way to handle things, because usually if a package is inherited by SLE, from SLE. In that case, we need to handle the packaging in a different way, directly with our test. We need to check who is the maintainer of that package, because you could submit your update without being the maintainer. So if you are the maintainer, you already are approving your fix, your proposal. But if you are not the maintainer will check the update and the submission. And if from the maintainer point of view, the update can be effectively delivered, in that case, we are starting to process this submission, and we are starting to do the process that I was describing before. If there are other issues with that submission, because maybe something is not properly fixed, or there is something else, maybe another fix pending to the same product, to the same package, we will directly contact you asking to fix what is needed, and usually we are reiterating the process until all the fixes are properly done, and everything can finally go out for the final release. So this is probably the main difference. From a developer point of view, obviously you can see much more interactions. You can also have the access to the tools, so you can directly see step by step which are the improvements. And at the end, like for the normal user, if the submission it's fine, if everything fulfill the requirements, we can finally achieve the final release of the submission.
Thank you, Marina. It sounds like a lot of work for a poor developer. I now have a tough questions, because Zoltan obviously is the part of the bad guy when it's down to a publishing of an update. He's the one that obviously needs to tell whether the update meets the quality expectations. So Zoltan, can you help me understand a little bit about how long it usually takes for a maintenance update to be released?
Yeah.
If everything obviously goes according to plan.
Yeah, if everything goes according to, of course, there are updates which we reject to release because they don't meet the quality standards. Then they run another round. So yeah, this is actually a number what I am following very close, and I have different numbers for different things, because this is actually like one measure of success. Quality is what we measure by regressions, emergencies, whatsoever, but time, how fast we can serve our customers, is essential. The median of pushing through an update, our workflow, is 8 to 10 days. That's pretty stable for years. Doesn't really change. It sounds lot or little, doesn't matter. But it's important to see details. For example, an emergency update can leave our doors in 0.5 to 2.5, 2.8 days. So emergency updates certainly do leave faster. For example, kernel updates, which are very important and essential, they don't spend in our pipeline longer than 4 or 5 days. So those are the topics of prioritization. Of course, if an upstream project, a change comes in with even a bug report, that customer reports that there is a typo in the man page, that's also something to fix. But naturally, we don't push as hard as an emergency or a security or a kernel update. So I'm not sure if I answered that, but the median is like 8 to 10 days, and I don't know if it sounds scary a lot or too little. I don't know that, but median is not really covering the full picture.
I think though it does give an idea of the amount of work and how long it takes anyway to make sure that when we are going to fix something, we won't be breaking anything else. because that's really what it really matters. So thank you, Zoltan, for explaining this to me. And Marcus, I would really like to ask you a final last question. After all this explanation, after all this process, the end user reporting the bug, the developer fixing it, and you guys obviously taking care of all the security, the quality, and making sure that this whole pipeline can work harmoniously. How does the end user know about an update, a maintenance update being ready? Because that's what the end user will care about.
Yeah. So so this is of course an interesting part for the end user. When does the update arrive? So of course he can run his update stack, Super or via SUSE Manager, and will install the updates. And actually, even on this level, they can look at the detailed description that Marina described, that for security would also include the CVE lists and the bugs that we fixed. And you can do that either on a single system level with Super or SUSE Manager or other management tools that you might have. For our customers, we also send out notification emails for both security and non-security updates, and they are also put in our website in a browsable fashion. Also in the SUSE Customer Center, you can look at all those patches in a patches view for your product, specifically search by keywords and so on. For security, we need to do also a bit more effort, because a lot of customers also have automated tools that they need to scan their systems to prove that they are compliant, that they have the CVEs fixed. So we provide also both human readable information about CVEs, about security issues on our website, and also for the updates. But we also provide automated machine readable information, so-called OVAL data, and also CVRF data, and potentially even more in the future, so that you can audit your systems with tooling like tools like openSCAP that implements the whole SCAP family for such auditing purposes. So both human readable information is provided, and machine readable information, and of course the updates.
Thank you, Marcus. This really means that the end user will always be able to really understand what an update is about. So there are no hidden secrets and nothing unexpected. Thank you. So, folks, I really enjoyed the time together. I think this is really interesting insight in how the maintenance, security, and QA world really works. And it proves that there is a lot of work to be done to ensure that an enterprise distribution could be shipped. So thank you very much for your work and for helping me here today, understanding the whole process. Very much appreciated. Thank you.
Thank you.
Thank you.
Bye-bye.
Bye-bye.